So welcome everyone, my name is Saurabh and I'm very excited to be here on Edureka Live with you guys. So today we'll be looking at Python code basics which are required for implementing deep learning models. After that there'll be one more session on machine learning and then I'll be telling you about TensorFlow, which is nothing but a deep learning library. So there'll be total 3 sessions. The first session will be about Python code basics, which is happening right now. Then I'll be talking about what is machine learning, and then finally in the third session I'll introduce TensorFlow, which is nothing but a deep learning library present in Python. Now before I begin guys, you can throw all your doubts in the comment section. Me and my team will try to answer those as soon as possible. So let's begin. So here we'll begin by understanding the use case that we'll implement in this session. After that I'll be discussing the fundamentals required to implement it. So people who already know Python can be a bit patient and wait till the end. And people who are not familiar with the basics of Python, just follow me through the session. So let's begin and understand the use case that we have. So here our use case is about analyzing the WHO data of life expectancy for all the countries from 1960 to 2012. But the question is, why are we doing it? So let's understand the importance of this use case. So by analyzing the pattern in life expectancy, we can understand how poor countries with low life expectancy is catching up with rich countries over the span of 1960 to 2012. So basically, it helps us in understanding the extent of health equality. After that, we can use this knowledge to understand a lot about health, social and economic condition of these countries. Now that we know the importance of this use case, we should focus on how to implement it. So for implementation, we'll quickly go through Python code basics. But first, let us understand what is Python. So Python is an object-oriented high-level programming language with some procedural concepts as well. And trust me guys, unlike Java and C++, the syntax of Python is very easy. It is very easy to learn. And it comes with a wide variety of application. You can use Python for testing, you can use Python for automation, you can use Python for machine learning, for deep learning. So there are wide varieties of application. And it is there in demand right now. Alright, so let us go ahead and understand the code basics of Python. So we'll begin by variables. So variables are nothing but reserved memory location to store values. What does this mean? This means that when you create a variable, you reserve some space in memory. And let me tell you guys, unlike Java and C++, here you don't need to specify the data type of your variable. That means it is basically a loosely typed language, alright? You don't need to specify the data type to which that particular variable belongs to. Next up, we'll see what are various data types available in Python. So Python supports various data types. These data types defines the operations possible on the variables and the storage method. So there are numeric data types, lists, tuples, strings, sets and dictionary. I'll discuss each of these data types. So for that, I'll open my PyCharm first. Alright, so we'll start with numeric data type. So what are numeric data type? As the name tells, basically numbers. There are integer numbers, there are float numbers and complex number. We know what are integer number, whole numbers, which actually include negative values as well. Float values are nothing but any rational number which can be represented in p by q form. Now when I talk about complex numbers, they have 2 components, one is real, another is imaginary. So in Python, you can perform typecasting. That is, you can convert an integer value to a float value and vice versa. But you cannot convert a complex value to a float value or an integer value. Neither you can convert a float or an integer to a complex value. Alright, so let us go ahead and I'll show you that. So I'm going to define a variable a and I'll store a value 10 in it. Then I'm going to define one more variable and I'm going to store a float value inside it. Alright, so now what I'm going to do, I'm going to convert the integer data type into float data type. So I just need to type here float and the integer value which is stored in my variable a. Let us go ahead and execute this. So you can see that the integer value was 10, but we have converted that to a float value which is equal to 10.0. Now similarly, you can do that in the other way as well. You can convert a float value to an integer value as well. So let me just show you. I'll keep it as b, which is nothing but a variable that contains my float value. Let us go ahead and run this now. So yep, instead of 10.01, we have got 10, which is nothing but an integer value. Now this is all about numeric data type guys. Next up, we are going to discuss what are lists. So you can consider the list as arrays in C, but in list you can store elements of different types, but in arrays all the elements should be of the same type. So if you are familiar with any other programming language, you must have heard about arrays. So in a particular array you can store the elements of one single data type. But when I talk about list, in list you can store multiple data types. You can store strings, you can store numbers, you can store different data types. So I'll quickly just create a list for you and I'll show you how you can do that. So just type the name of your list. Then the elements that you're going to define, just put that inside square braces, alright? So I'm just going to create a student list and I'm going to put in some dummy names here. Ross, Emily, Joey. So all you people who like watching Friends, you can actually relate to these names, right? So I'll just quickly go ahead and print this student list. So you can see that the list has been printed. Now there are various operations that you can perform with this list. You can find out the length of this list. You can find out, you can perform slicing over here. You can find out the index value of a particular element. So let me show you how you can do that. First, I'll show you how you can print the length of your string. Just type in len and the name of your string, name of your list. I'm sorry. Just go ahead and execute it. So yep, it has 3 elements, as you can see, as you can see in the output as well. Next up, you can perform slicing as well. Let me show you how you can do that. So like any other programming language, indexing in Python also starts from 0. So this will be my 0th element, this will be my first element, and this will be my second element. So if I want only Ross and Emily to be printed, what I can do is, I'll just type in here print students and then the range of the index. So I want to start from 0th index, and I want to include the first index, but I don't want to include the second index. So it will go till 0, it will start from 0 till the second index. So Joey won't be printed here, only Ross and Emily. Let us go ahead and execute this. So yep, you can see that Ross and Emily has been printed. Now if I want only one single element to be printed from my list, I can just go ahead and do that. So if I want only Joey to be printed, I'll just type in here the index value of Joey. I'll go ahead and execute this. So yep, you can see that it has appeared. Now I can even reverse this particular list. Let me show you how you can do that. So I'll just type in here : -1. I'm going to reverse the indexing. So it actually starts from 0, 1 and 2, right? So when I go in the reverse order, it'll start from -1, -2 and -3. So I'll just go ahead and execute this. And yep, as you can see that my list has been reversed. So this is all about lists, guys. Next up, we are going to discuss tuples. So a tuple is a sequence of immutable Python objects. When I say immutable, what it means is I cannot make any changes to my tuple once I've defined it. Unlike lists, which are mutable, I can add an element, I can delete an element in a list. But when I talk about tuple, I can't do that. Once I've defined a tuple, I cannot make any changes to it. And that is one major difference between a list and a tuple. Apart from that, when I talk about syntax also, in a tuple, you need to enclose your elements within the parentheses, not the square braces. Alright, so this has now become a student tuple for me. And you can perform all the operations that you can that you have seen in a list. The same operations you can perform with tuples. The only difference is you cannot add an element, neither you can delete an element from a tuple. Now, there's an obvious question that must be there in your mind is, why are we using tuples when we have list? So tuples are faster than list. If you're defining a constant set of values and all you are ever going to do with that is iterate through it, that's when you can use tuple instead of list, because it is faster than list. Alright, so yep, this is all about tuples. Next up, we are going to discuss sets. So what is a set? A set is an unordered collection of items, and every item in a set is unique. Now let me just define a set for you. I'll just name it as set equal to, and the syntax is I need to enclose the elements within the curly braces. So I'll just put in some numbers here, 1, 2 and 3. Now let us go ahead and print this set. So yep, it has appeared here. Now what I'll do, I'll repeat 3 twice and I'm going to execute it and we'll see what happens. So over here also you can see that 3 has appeared only once, although in my set it is there twice. So as I've told you earlier as well, set is nothing but an unordered collection of unique items. So every item in your set should be unique. Now there are various operations that you can perform with set. You can perform symmetric difference, you can perform intersection, you can perform union. There are a lot of operations that you can perform with set. And I've shown all these operations in my Python programming video, so you can go through it. Next up, we are going to discuss dictionary. So let me explain you what exactly are dictionaries. Now I'm guessing all of you must have heard about Aadhaar card. For those of you who don't know what it is nothing but a unique ID which has been given to all Indian citizens. So for every Aadhaar number, there is a name and few other details attached. Now you can consider this Aadhaar number as a key and the person's detail as a value attached to that key. And that is what dictionary is. Dictionary basically contains key value pairs. So there'll be a key and to that key there'll be a value attached. Now let me create a dictionary for you. So I'm just going to type in here dict equal to, and like set only, I need to enclose all my elements within curly braces. So my first key will be name. I'm just going to type my name here. And my second key will be age, and I'm going to type in here my age. Now let's go ahead and print this dictionary. So yep, as you can see, that dictionary has appeared now. So these are all the data types available in Python. Next up, we are going to focus on operators. So for that, I'll open my slides once more. So Python comes with these very operators. There are comparison operators, identity, logical, arithmetic, assignment, bitwise, membership. So for this session, I'll only focus on arithmetic operator, comparison operator, and assignment operator. Although I've discussed all these operators in detail in my Python programming video, so you can go through it. Now what I'm going to do, I'm going to open my PyCharm once again, and I'll explain it to you, arithmetic and as well as assignment and comparison operators. So arithmetic operators is basically used to perform all the arithmetic operations. It can be addition, subtraction, multiplication, division, modulus, and exponent. Alright, so what I've done here, I've defined three variables A, B, and C with values 21, 10, and 0 respectively. Now over here I'm first performing addition. I'm just adding two values A and B and I'm storing it in variable C. And similarly I am performing subtraction, multiplication, division, calculating the remainder as well, and then finally exponent value. So I can just go ahead and execute this quickly for you. So these are all the values. 31 comes after addition, then subtraction, multiplication, division, remainder, and exponent. Next up, we are going to discuss the comparison operators. So these comparison operators are used to compare the values on either sides of them and decide the relation among them. So it can be equal to, it can be not equal to, all those kind of stuff. So again over here as well I have defined three variables A, B, and C with values 21, 10, and 0 respectively. Now over here I am using conditional statements if and else, although you'll understand this conditional statement later in the session, but over here I'll just give you a brief introduction, a small introduction of what it is. So when I write if, and the condition here says that A should be equal to B, then only the subsequent statement will be executed. So here it is a print statement which says that A is equal to B. And when this is not the case, I mean when the condition is not true, then the else statement will be executed. Similarly, this actually shows that A is not equal to B. This shows that A is less than B. This is for A is greater than B, less than equal to, greater than equal to. Alright, so I'll just go ahead and quickly show you how the output looks like. So this is the output, guys. Next up, we are going to discuss assignment operator. So an assignment operator is the operator used to assign a new value to a variable. Let me explain you with an example. So for assignment operators as well, we have taken three variables A, B, and C with values 21, 10, and 0 respectively. So we have initialized C with the addition of A and B, and we are printing that particular value. After that, what we are doing, we are just typing it as C plus equal to A, which means that C is equal to C plus A. So basically, after adding C and A, the value will be stored in C. Similarly, after multiplying C and A, the value will be stored in C. Same goes for division, modulus, and exponent as well. I'll just go ahead and quickly run this for you. So these are all the values that comes after addition, subtraction, multiplication, division, modulus, exponent, etc., etc. So these are all the three. These are the three operators that I've actually discussed today. If you want to know more about these operators, you can go to Python programming video. I'm saying this again and again. So it's a very detailed video. You can understand all the different types of operators that are there in Python. All right. So I'll again open my slides. Now we are going to understand conditional statements. So conditional statements are used to execute a statement or a group of statements when some condition is true. And in Python, there are namely three types of conditional statement: if, elif, and else. Now let me explain to you with the flow chart. So the control will first check whether the if condition is true or not, whether if x is less than y. So when this is true, it will execute statement underscore A. And when it is false, it will check the elif condition, whether x is greater than y or not. And when this is true, it will execute statement underscore B. But when even this is false, it will go and check the else condition. And then after that, it will execute statement underscore C. So I'll quickly open my PyCharm and I'll show you that. So over here, I have two variables, x and y. And in x, I have assigned value 11, and in y, I have value 10. So the first if statement says that if x is less than y, print x is less than y. Elif x is greater than y, print x is greater than y. And else, you don't need to specify any condition here. It will take the default condition, which is x is equal to y. Alright, so we know that actually x is greater than y. So it should print x is greater than y. Let us go ahead and execute this and we'll see what happens. So x is definitely greater than y. Now, what if I make y greater than x? Then it should print x is less than y. And yep, it does. And I can make it equal and it will execute the else statement. And yep, x and y are equal. So this is all about conditional statement, guys. Let me open my slides once more and we'll see what is next. Now we are going to understand what are loops. So I'll first explain why we need loops. Now in general, statements are executed sequentially. The first statement in the function is executed first, followed by the second, and so on, right? This is a general scenario. But there might be a situation when you need to execute a block of code several number of times. So basically, a loop allows you to execute a statement or a group of statement multiple times. So I'll explain you with the flow chart. So the control will first start and it will check the condition here. So if the loop condition, this condition is true, then it will go ahead and execute the conditional code, the code which is written inside the loop. Then again it will check the condition. If it is again true, then again it will execute the conditional code. And this process will keep on repeating until your condition becomes false. And the moment it becomes false, the control will come out of the loop. So you can actually create an infinite loop as well. Now in Python, we have three types of loop: while, for, and nested. I'll explain each of these. For that, I'll open my PyCharm. So a while loop is basically excuse me. So in a while loop, first the condition is checked, and if it's true, control will move inside the loop and execute the statement inside the loop until the condition becomes false. But the question is when we use this loop. So we use this loop when we are not sure how many times we need to execute a group of statement, or you can say that when we are unsure about the number of iterations. Alright, so let me explain you this with an example. So over here we have defined a variable count and we have initialized value 0 to it. After that I'm using the while loop, and inside that while loop the condition says that count should always be less than 10. So the moment my count becomes greater than 10, it'll come out of the loop and it'll print goodbye. But when it is less than 10, it'll enter the loop, it'll print that particular count value, then it will increment the count value by 1, save it in the count variable again, and then again it will check the loop condition whether it is still less than 10 or not. If it is still less than 10, it'll print the count value. And the moment it becomes greater than 10 or equal to 10, it'll come out of the loop and it'll print goodbye. So let us see if that happens or not. So yep, you can see that 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 has been printed, and since our condition says that count should be less than 10, so that's why it came out of the loop after 9 and it has printed goodbye for us. Now we are going to understand for loop. So like the while loop, the for loop also allows a code block to be repeated certain number of times. Only difference is in for loop we know the amount of iterations required, unlike while loop where iteration depends on the condition, right? So I've taken an example of students again here, Emily, Ross and Joey, and I'm using this list, so I'll iterate through this list only. So I'm typing here for index again index starts from 0, 1 and 2, in range length of my students list, print the student index. That means if my index value, I'll start from 0 and it is within the range of my list, then what will happen, it will print the value that is associated with index 0 in my list student. Again it will take second index, that will be index value 1, again check whether it is in the range of the student list, and if it is, then it will print the value associated with index value 1, and similarly for 2 as well. Let us go ahead and execute this. So yep, Emily, Ross and Joey has appeared here. So this is all for loop, guys. Now when I talk about nested loops are nothing but using a loop inside a loop. So you can use a while loop inside a for loop inside a while loop, a for loop inside a for loop, and a while loop inside a while loop. That is nothing but your nested loops. And nested loops. And I've explained nested loop as well in my Python programming video. Now we are going to discuss what are the various functions. So what are functions basically? So for that I'll again open my slides. So functions are a convenient way to divide your code into useful blocks. And this allows us to order our code, make it more readable and reuse it. So let me explain you with an example. Suppose in my code I need to add 2 values multiple times. So I have to write that logic to add 2 values how much ever time I want it there to be in my code. But an easier way will be I make a function that adds 2 value and then it will return the value that comes after adding those values. Alright, so I'll make a function like that will add 2 values, and then whenever I want to add 2 values in my code, I can just call that function, feed in the values to that function, and then it will return the value that comes after adding those 2 values. Alright, so I'm going to create the same function in my PyCharm. So the syntax here is def name of your function, then parameters, given a colon, and then just return a plus b. Right? So now this is a function that will add 2 values. Now what I need to do is I need to feed in 2 values. So I'll create a variable c, and I'll just call this add function and feed in values to this add function. So I'm going to feed in 10 and 20. Finally go ahead and print c, and you'll see that the values have been added and we have got the output as 30. Alright, fine guys. So I'll go back to my slides once again and we'll see what is next. Now before we actually implement deep learning models using TensorFlow, we need to understand a lot of Python libraries. Namely, 3 most important libraries I can think of right now. So there are 3 libraries which are very important when you are executing your deep learning models with TensorFlow. The first is NumPy, then Pandas, then Matplotlib. So I'll discuss each of these libraries one by one. But before I discuss that, let me tell you, I have a detailed tutorial video on NumPy, Pandas and Matplotlib. So you can go through that anytime you want if you have any doubts. So what is NumPy? NumPy is the fundamental package for scientific computing with Python. It contains a powerful n-dimensional array object. And it is very useful for linear algebra, Fourier transform and random number capabilities. Now I've taken an example of a multi-dimensional array here which has 4 rows and it has 3 columns. Alright, and again, like other programming languages, indexing starts from 0. So when I'm referring to A00, that means this particular value which is 1. So always when you are providing an index value, you need to provide the index value of your row first, and then you need to provide your index value of column. So when I write A2 comma 2, it is actually pointing towards this particular value, which is 10. Alright, so let me just quickly open my PyCharm and I'll show you how to create a NumPy array and various operations that you can perform with NumPy. So before I explain NumPy, before I actually practically show you how to create a NumPy array and various operations with NumPy, let me tell you guys, a lot of people ask this question, why are we using NumPy when we have list? Now let me tell you guys, NumPy is way better than list. And on what terms I'm saying that is because it occupies less memory, it is faster than list, and it is more convenient than list. I have actually practically proven these 3 points in my NumPy tutorial video, so you can go through that. Now I'll just take this convenient factor here and I'll compare list and NumPy. So when I actually write list L1 plus list L2, that will give me a list which will be combination of both the lists. So it will concatenate both the lists. But in NumPy array, if I have two NumPy arrays N1 and N2 and I type in N1 plus N2, so it will give me the values that comes after adding both the NumPy arrays. So that way it is convenient. Similarly, it is faster and occupies less memory. So you can go through that video and where I've proven it practically why it is that. Alright, so let me first comment these lines so that I can show you how to first create a NumPy array, and then we'll see the various operations that you can perform with it. Alrighty then. Fine. So first thing we need to do is import the NumPy module or the NumPy library as np, nt, ns, whatever you want. I'll just keep it as np. So import NumPy as np. Now if you want to install any module through PyCharm, what you can do is go to File, click on Settings, Project Interpreter, click on plus, and type the name of the module that you want to install. Say if you want to install NumPy, just click on NumPy, you'll see NumPy here, click on Install Package, and it will be done for you. Alright, so I've already installed NumPy, so I don't need to do it. So import NumPy as numpy. After that, I'm going to create a NumPy array, and the values that will be there in my NumPy array are these values. And then I've defined the data type of these values, which will be float 64 bits. Now over here, if you can notice that we have 3 rows and we have 2 columns. So let me just show you by running this. So yep, we have 3 rows and we have 2 columns. Now what I can do is I can actually convert this 3 rows 2 columns to 2 rows and 3 columns. For that I just need to call this reshape function that I've written here, and the value that you want after, basically how you want to reshape it. So I want only 2 rows and I want 3 columns instead of 3 rows and 2 columns. Let us see if that happens or not. So this is our original NumPy array, and this is the NumPy array we get after reshaping it. So it has 2 rows and 3 columns. Perfect, guys. Now what I can do is I can actually calculate the minimum and maximum value from my NumPy array as well. So my minimum value is definitely 1 and my maximum value is 4, which has appeared here, right? Next up, we can actually perform the sum of all the columns as well as rows. So when I write axis 0, it represents columns, and when I write axis 1, it represents rows. So when I add columns, the value that should be printed will be 1 plus 1 and plus 3, which will be 5, then 3 plus 2 plus 4, which will be 9. And when I add rows, it should print 2 plus 1, 3 plus 1 and 4 plus 3. Let us see if that happens or not. So yep, we have got the values that come after adding the columns 5 and 9, and after adding the rows, we have got 3, 4 and 7. Then what I'm going to do, I'm going to calculate now the square root, and let me show you how you can do that. Just call in this sqrt function, and it'll display the square root of all the elements in the NumPy array, as you can see it over here that I'm highlighting right now. So square root of 1 is 1, 2 is 1.414, then 1 is 1, again square root of 3 is 1.73, similarly square root of 3 is 1.73, square root of 4 is 2. Alright. Now I can even find out the size of my NumPy array as well as its shape. So when I talk about size, basically it talks about the number of elements present in your NumPy array. So when I execute this, the size of my NumPy array is 6. That means there are the total 6 elements in my NumPy array, and the shape is 3 rows and 2 columns. Now comes another part where I am going to define a NumPy array. So basically what I want a particular shape, and that shape should be filled with zeros, and it should be a NumPy array. So the shape here that I have defined is 3, 4, which means 3 rows and 4 columns, and all of these rows and columns should be filled with zeros. Let us see if that happens or not. So yep, you can see that we have 4 columns and 3 rows, all are filled with zeros. Now I can even fill it with ones as well. So for that I just need to type in here ones, go ahead and execute this, and yep, you can see that all ones have appeared here. Alright, the final thing that I'm going to explain here is line space. So basically if I have say a range, for example 1 to 5, and I want suppose 10 values to be printed between 1 and 5. So I just need to write in the range first, 1 to 5. Then how many values between that range, that's all. So it will print 10 values between 1 to 5. Let us see if that happens or not. Yep, it has printed 10 values, and if you don't believe me, just start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Alright guys. So done with NumPy. I'll open my slides once more. Now, matplotlib is basically used for visualization. So any sort of graph that you can think of, bar plot, histogram, scatter plot, pie chart, anything that you can think of, any sort of graph you can think of, you can execute that with the help of matplotlib. So I'll explain this when I'm talking about the use case implementation part. Alright, and there's again a separate tutorial video on matplotlib, so you can go through it. Now we are going to discuss pandas. So basically, the pandas module uses objects to allow for data analysis at a very high performance rate in comparison to typical Python procedures. And with pandas, we can easily read and write from and to a CSV file or even databases. And from there, we can manipulate the data by columns, create new columns, and even paste the new columns on other column data. So again, I have a separate tutorial videos on pandas, you can go through it. So for now, I'll open my PyCharm. So first thing you need to do is import pandas as PD, PL, PN, whatever you want to write. I'll just keep it as PD. And I've defined a dictionary here. The name of the dictionary is web_stats. So it has various stats about our website. Say the number of days, 1, 2, 3, 4, 5, 6. Number of visitors. So visitors on the first day were 43. On the second day were 34. Similarly, on the sixth day were 76. Now there's one more key, which is bounce rate. So bounce rate is basically few people who actually go to a website and suddenly they realize that this is not what they're looking for, so they directly move out of that website, right? So they'll directly leave the website. So that is nothing but bounce rate. So this is a dictionary, alright? And what I will do, I'll convert this dictionary to a pandas data frame. How I can do that? Just typing in PD and calling in the data frame function. And over there, I'll just feed in the value of this dictionary. So let me just comment these lines. Alright? And now I'm going to execute it. Sorry, I just forgot to print this data frame. Yep. So yeah, now you can see the difference between the two. So over here we have defined a dictionary, but here we have created a pandas data frame using that dictionary. Now over here, if you notice, these are nothing but index values 0, 1, 2, 3, 4, and 5. Now with pandas, you can change this index value, you can remove this index value. If you want, suppose any of the columns to become your index, that can also happen. Suppose if I want my day to become my index, that can also happen. So there are like multiple operations that you can perform with pandas. So you can go through the pandas tutorial video where I've explained properly how you can perform those operations. For now, I'll stick to very basic operations. Alright, so what if I only want the first five rows of my data frame to be printed? So for that, I'm just going to use this head function. And the moment I execute it, you can see that only 0, 1, 2, 3, and 4 has printed, not 5. Because I want only 5 rows to be printed, and not to the top 5. Now, similarly, if I want to execute, say, if I want to print the last 5 values, I just need to type in df.tail. So yep, you can see that instead of 0, that's all the values have been printed. Now, there might be a situation where I only want the starting 2 values, alright, or the ending 2 values. So I just need to define that. I just need to write that basically. So this basically what it'll do, it'll actually print the last 2 values of my data frame. So let us see if that happens or not. So yep, only the last 2 values, 4 and 5. Similarly, I can make this as head and it'll print the starting 2 values for me. Yep, 0 and 1 has been printed. So this is all about pandas, guys. I'll go back to my slides once more. So now is the correct time to implement the use case that I was talking about in the beginning. So for that, again, I'll open my PyCharm. So I've already written the code in order to execute the use case. So here what I'm doing is, first of all, I'm importing the important libraries. I'm importing pandas, matplotlib, numpy, and I'm even importing style from matplotlib. Then I'm using ggplot. After that, as I told you earlier as well, that you can read the CSV file through pandas data frame. So this is how you can do through pandas. This is how you can do that. So pd.read_csv and just give the path to your data set. Alright. And after giving the path, this use call basically tells that I only want to use these 3 columns: country or area, year, and value. Sorry guys for that disturbance. So I'll again actually explain you this code. I'll start from the beginning. Over here, what we need to do is the first step is to import the libraries that are required. We'll import pandas for reading the data set. Then we're going to import matplotlib. We're going to import matplotlib for visualization. Then we're going to import numpy as NP for multi-dimensional arrays. And we're also going to import style from the matplotlib library. All right. And what I'm going to do is I'm going to read the CSV file, and for that what I need to do is just write pd.read_csv, and within the parentheses just give the path to your data set. Alright, just give the path to your data set, and once you are done with that, I specified the columns that I'm going to use from that data set. So I'm not going to use all the columns, I'm just going to use country or area, then year and value. So these three columns I'm going to use. Fine, so once I'm done with that, what I need to do is I am defining a numpy array, and in that numpy array what I'm doing is I'm trying to get all the unique countries from my data set. So my data set has a lot of countries, and over there what happens is a country has been repeated say 52 times, because from 1960 to 2012 it is calculated. There's one more column which tells about the life expectancy of these countries from 1960 to 2012. So every country has been repeated 52 times, but I want to create a numpy array which has only the unique countries in my data set. Alright, once I'm done with that, I'm creating a data frame df2 which will actually include the country which has index value 0 in my numpy array. So I know it is Afghanistan because that is the first country, and similarly I'm going to define one more data frame df3 which will have the first country which will have the country which has the first index in my numpy array. Similarly I've done that for a few of the countries, and and after that what I've done, I've just used the pld.plot function, and over there in my df2 data frame 2 I just want the year value and I want the life expectancy value. And after that, this is basically, it tells the color of my line, so it'll be red. Even if you don't specify it, it doesn't matter. Alright, it'll automatically take the unique color. And line width also, you don't need to specify it. I'm just showing you, it's just for the demonstration purpose, I've done it here. Alright, similarly, I've done with df3 as well. I only want the year and value, and color, you can, you don't need to do it. You can just leave it blank and just close the parentheses after your value. Alright, once you are done with that, I've defined a legend. So basically, this legend will describe to which line a country belong to, right? Which color line a country belong to. Once I'm done with that, I'm going to use grid lines. So it is basically to add a bit of style to my graph. You can just skip that part if you want to. Alright, and then I am giving a title to my plot, which is WHO, and I'm defining Y label and X label. So my Y label will be life expectancy and X label will be year. And finally, show the plot. So let us go ahead and execute this. So yep, this is how our plot looks like, guys. So over here we can see that there are few countries in which the life expectancy was pretty decent in 1960 as well, and they have not improved as they have not improved drastically. There's not a drastic change in their life expectancy. But there are other countries. If you see Cambodia here, so in Cambodia in 1977 their life expectancy was around 20 because of political conditions and the health issues with the people out there, so because of multiple reasons. But from there they have picked up, and their life expectancy is somewhere around 70, above 70 actually. So this is a drastic change, guys. Similarly, you can see for Afghanistan as well. Afghanistan, their life expectancy was around 30 in 1960, and you can see how well it has, how much they have improved, right? So this is how you can plot the life expectancy versus the year plot. All right. Let me just give you a quick recap of what all things we have discussed till now. For that, I'll open my slides once more. Alright, so we started with the use case. We understood what we are going to implement in today's session. After that, we understood what exactly is Python, and we saw various code basics. We started with variables and data types, operators, condition statements, loops, functions, all those things. Then we saw how to actually implement the use case. For that, we used three libraries: pandas, matplotlib, and numpy. And I've given you a small introduction on all of these three libraries. Now guys, that is it for today's session. So what I'll do, I'll just quickly open the Edureka's course landing page for Python and deep learning. Alright, so this is basically a Python certification training. So if you want to enroll for live online instructor-led training with 24/7 support and lifetime access, you can enroll here. It'll teach you all the basics of Python and various libraries as well, like Pandas, NumPy. All those things will be covered in detail in our Python certification training. And if you're a bit comfortable with Python, you can go for deep learning with TensorFlow as well. And over here also, if you want to take it directly, you can do that, because we provide a complimentary self-paced course for Python Essentials for TensorFlow. Alright, and again, all the classes here are live online instructor-led training, and you'll get 24/7 support, as well as you will actually get the lifetime access as well. Alright, and let me show you the playlist for deep learning videos. So this is the playlist where you can find all the deep learning videos by Edureka available on YouTube. Similarly, we have a playlist for Python tutorial videos as well. Alright, and after that I'm going to show you a blog series on deep learning. So it will include some 5-6 blogs, so you can just go through those blogs. And let me just show you the bell button. So basically, you need to first subscribe to our channel and click on this bell button, so that you'll be notified if if anything is uploaded on YouTube, or any notification by the channel, you'll be notified about it. Alright. Thank you guys for attending today's session, and the next session will be on machine learning with Python. So in the meantime, you can go through the videos of NumPy, Pandas, Matplotlib, and Python programming. So the link will be shared in the comment section. So just go through all these videos before you attend the next live session on machine learning. Thank you, and happy learning.